everybody. Thank you for joining us today on this webinar about our open pit solutions for long-term planning. I am Beatrice. I am part of the Datamine Africa team and also the open pit team. And I will present this for you today. I have Gustav as my team lead, and he's also my co-presenter today. So at the end of this presentation, we will answer a few questions. And if you have anything in the middle of the presentation that you want to question later, please write it down or write there on the chat and we will answer them by the end. Okay? The main goal of this webinar today is to show you guys how our solutions are integrated with each other and how the information flows between one solution and the other and what is the value that we are adding between those solutions. That's why I want to give an overview of our open pit solutions for planning before we move forward and detail into each one of them. So here we have our three solutions. They are NPV Scheduler, Studio P, and EPS. NPV Scheduler works on the optimization part of Life of Mine project. So the main goal of NPV Scheduler is to maximize the NPV value and the cash flow of the pit based on an economical model, creating the Lash-Grossman phases, and after setting up the pushbacks and all the other constraints, it gives us an optimized extraction sequence, also in a block model form. So NPV Scheduler has a block model as an input, a lot of parameters, economical parameters that we're going to look into later. And the output of it is also an optimized block model with a sequence of extraction inside. Um, Studio OP, on the other hand, is a design and scheduling tool. It doesn't have an optimization into it. So Studio P works with short and long-term planning. It works with surfaces and GTMs, so you can load in your real topo, do your real pit design, and create your operational blocks. The main value that it adds is this. So you input your optimized block model in Studio P and you use it to calculate and read the sequence that it was created on NPV inside of your block solids. So you take a mathematical solution and you add into your operational solid. And EPS is a scheduling tool. So once we have our operational solids, we can create a schedule inside of OP and report it, but we can also export it to EPS to easily create different scenarios, add new machines, look into live dashboards, everything that EPS can give us with the Gantt charts and fully integrated with Studio OP. So the solids on OP can be connected to EPS and you can look at the sequence that you are creating inside EPS. Okay, so again, the main goal of this webinar today is to show you how the information flow between one solution and the other and how the information also flows with it and it's not lost on the way. Cool? On NPV Scheduler, I'm going to quickly go through the workflow of a Life of Mine project. Again, the input of NPV Scheduler is a block model where we must have defined some attributes on them. So we can define our product, what are rock types, and This is where we're going to base our NPV result. The main goal of NPV is to calculate the best mathematical solution that maximizes the NPV of our operation. So on every step of this workflow, we're going to add more details into our operations to try to represent the reality of what we have on our daily operation. So we import our block model, we define our projects, we define our slope regions and all the attributes we want to report. Then we calculate our economical model based on this block model. This is where we add all our input parameters. And remember, our optimization is only as good as the parameters that we input on it. So this is a crucial part of your project. This is where you should get the all of your attention on how to gather those parameters so they can represent your operation. Based on that economical model, NPV Scheduler calculates our last Grossman nested bits using the incremental price percentage to create the the phases and calculate the NPV value for each one of them. This is the point where we define our final bit and what's gonna guide us to the next steps of the way. I'm not gonna give a lot of detail on this because this is not the goal of this presentation now, sorry. Mm, but when we define our final bit, that's when we can address our practical pushbacks. Why do we call it practical pushbacks? This is because we can define a lot of constraints on this part. I'm going to show that on the software. But after we define our practical pushbacks, we define our optimized schedule based on this pushback inside our final bit. So you see everything that flows on this workflow depends on the step before. So that's why it's very, very important to have the right block model, have the right parameters to create your economical model, and so on. I will start showing you a little bit more about the constraints that we can add on our pushbacks. This is the NPV layout. The constraints we can add on our pushbacks are the mining width. So what's the mining width, the minimum mining width for each pushback? And we can do a size control based on the tonnage and on the benches that we're gonna mine per pushback. In this case, I'm using different benches. And here again, you can define which one of the phases represent your final pit. Once we define our pushbacks, we can have a report of how our pushback look like. I can quickly show how this report looks like. So we have the amount of rock tons per pushback, the NPV for each pushback. This is a cumulative data, just keep that in mind. And how much of ore tons and waste tons we have on them as well. On the scheduler part, this is where we add the more and more detail to our operation. So we can calculate the best extraction sequence for your pit. So here you can see you can add stockpiling, haulage, and capital cost information. I'm not going to go through into detail of that fields, but once you add those things, you adding more costs, more information to your mine, and then you can NPV scheduler can recalculate your NPV and try to find the best extraction sequence that still maximize your NPV based on more and more constraints that you add, more and more details that you add inside of your operation. The result of that run is a report based on time periods, on this case are quarters, and you have the information for rock movement, the costs, and NPV and tonnage. So you can see here for every one of these periods, what are the results that you're getting. An important feature that we have on NPV that is very good to point it out is that we can create a lot of scenarios to do the sensitivity analysis. You can quickly copy and paste your base case and then create the scenarios. And you can also analyze different scenarios for you and your mind, oops, depending of what you're looking for. Now that we have a sequence on, we calculated a sequence on NPV, we can export all this information inside a block model. Here we just come to data, export model, and you're going to see we can select the information that we want inside our block model. So we want economical fields, all the economical fields, the information of ultimate pit design, pushback, and scheduler. And here we're gonna have, it's gonna ask us what's the format that we want to export that block model. I'm gonna choose the Datamine block model, and you can save inside of any folder that you want. I'm gonna save on this one. It's gonna give me this error because I already exported it once. And then we can go to Studio OP to visualize it. I already imported inside Studio OP. So, oops, sorry. It's already following the sequence here. And this is already, it's also the mathematical shell that contains our pit. I'm gonna animate again, following the sequence from NPV. And animate it back. So that means that everything that we created on NPV is already inside of OP in just a drag and drop action. So once we are inside of OP, we need to follow its workflow. I'm going to give a quick overview of how the workflow from OP works. Um, this is how it looks like. We have 3 different ribbons, but 2 different steps. So the setup ribbon is where we define our files like the topo, the model, the bench height, and the phases, the number of phases that we are using. If you watched the webinar about the auto design, Gustav explained a little bit more, a few features of the setup ribbon and the design, the phase design portion of it. So this is the first part of the research process, is creating the automatic design or even a manual design if you want. I don't see a reason for that now. But especially on the long-term part of it. Once we have our phase designs, we can create the DTMs of it and then create the solids. This is when we close our pit design with the topo we defined, and then we create our solids. We cut them into the benches we defined, and then we can create mining blocks and add dependencies to those mining blocks. They can be spatial or a sequence. That means spatial is between benches or inside the same bench. Before, oops, we add all this information inside into the schedule ribbon. One good thing to remember is that everything that you set up on the research process and on the setup ribbon it stays saved on a database. This is really good for sharing projects, so it's really good to remember that everything stays there. Okay? With that in mind, we can go back to Studio OP and understand a little bit of the things better. So one thing that I want to show is that when we go to the setup and we define our block model, if we are importing something from a block model from NPV, all the NPV information will be here already, and Studio OP will automatically read it. So that means all the economical fields will be here and the sequence fields as well. That means that when we evaluate, when we put the block model information inside of solids, all the information will be there and will be the same that we exported from NPV. Okay? One thing that I want to talk about here, this is just a comment, is that we have two options when creating mining blocks. One is the automatic way, that is the one that I use for this project, that is based on a time frame and a mining rate, and the manual that you can define your grid or use automatic gridding to your project. So once we are done here, we can evaluate based on a legend and on a block model. On this evaluation, this is where we add the block model information inside of the solid information. And we can, once the evaluation is done, you can look at the results. We have a block ID. This represents every one of the block solids, every category. So this is the same category for the same block ID, different categories for the same block ID, and all your attributes information based on the definition table that we set it up before. Okay. Once we are done evaluating, we can create the dependencies if you want. And this is a very important step, that is to create your data set. The data set is just when the Studio OP puts together a folder with all the information that you need as an input to your schedule. So your data set will always have a solid file, an outline file, and a reserves file. So this is the basic information for you to create a schedule. And it also stays saved inside the OP database for your project. Okay? So you can create different scenarios and test and schedule them differently. On the schedule ribbon, you can select your data set that you created previously, create a new mining schedule for you, and even import or export settings for your schedule. On the reporting part, we have this very cool feature up for Excel reporting that we can export our schedule based on an Excel template. We just need to define what is the sheet that we are pasting the database into it. So when we say OK, it gives us the solid of our pit. I'm just gonna show with the DTM so we can have some background to it. Everything is already defined. I'm not gonna go through this. This is a 6-month calendar, semester, and you have the options to define your targets, and you can keep track of them right here. So let me close this. This is where you get your schedule. In this case, we haven't mined anything, so that's why we don't we have 0 tons. We can define activities for drilling and blasting, and we can do the schedule. Since this is a life of mine project, you can select your blocks one by one if you want. But since this is a long-term plan, I'm gonna select all the blocks. I'm sorry, to put this. I'm gonna select all the blocks and I'm gonna mine them based on this sequence attribute. The sequence attribute is the same attribute from NPV that Studio P normalizes and adds into your mining blocks. So Studio P reads the information that we set it as our sequence number in our block model, evaluates it, and normalize it inside every one of your mining blocks. And then we can schedule it, select what is the machine we are using to select. This is already defined here. I'm not going to go through this. And then we can say, okay, we can overload it, even for the trucks. And here we have the option to spill over, because you see everything that is red is what is being overmined over the capacity of the machine. Okay, I'm not going to do this because this takes a little while since it's a full life of mine. And I'm going to add my long-term schedule that is already done. Okay, just gonna delete this one for now so we don't have any problems. I'm gonna color this by face. And as you can see, we are already mining some things on period 1. Our targets, they look different. So you see we have the actual, what is the difference between my target definition and what I really have it, if it's met or not met. And then we can animate this based on the sequence that I'm following. Just gonna stop this. Another cool thing that we can report on OP to represent the reality of our mine is the nodes. That means the plant and waste location, the pit exits, and the bench exits. That's all for our haulage network. We can also define what are the paths that our trucks can follow. We can add a lot of details into the trucks, like rim and rule information, truck information, and we can do this for the haul routes as well. Everything that we are doing here, we can export to Excel into that template that I showed before. As you can see here, we have the schedule database with all the information. So the tonnage, what is the destination of the blocks, and what is the ramp sector that it's following. And everything feeds different pivot tables. This one is for tonnage, for plant and waste tonnage. This one is for product and the haulage information as well, such as the haulage distance for the trucks, and the truck hours. Another option that we have is to export our mining blocks to our other software, EPS, and do the schedule there. So I'm going to use the synchronize option that we have here on EPS just because I can use a template to it. That is great for reporting purposes. I have the project ready here. EPS layout looks like this. We have our task table, our Gantt chart table, and our cross tabs tables here. Here is where we get all the reporting. So in this case, I'm reporting the tonnage and the AU grams and CU grams as well. And here is where we have our tasks. Another way that we can report are the live dashboards. There are all those tables here. We can create as many as we want. On this case, the 4 of those will guide us into our schedules. Um, this is a yearly tonnage graph. This is a quarter tonnage graph, and the same follows for the AU grams. Right now, I'm using the same configuration as the Studio OP. So every one of the tasks are assigned with the loader 1. And to level my schedule, I'm using the sequence number. I'm not following any targets. That's because I am reproducing the same schedule from OP just to prove to you that all the information that I have on OP, I have it as well on EPS, just on the synchronization button. So if you look at the dashboards and you compare them with our Excel dashboards, tables, you can see that they look almost the same. And for we have this downward tonnage here on 2025. This is where we have our down into period 13. And we have the same here and the same thing on the quarters. Remember, this is a 6-month period. This is yearly and this is quarterly. Before we create a new scenario on EPS, I want to show how we can connect EPS to the solids here on OP. If you just right click and link to EPS based on the block ID, and we have here this EPS tab that reads all the information from EPS. Now the sequence looks like this because the EPS sequence bar is already at its end. But this is the solid, and as you can see, I'm gonna show how we can connect, how they are connected. So every time that I select a task here on EPS, it's selected on OP. And if I select a task on OP, they will also be selected on EPS. So they are fully integrated. Okay. And now I know it's too much information. Thank you for giving me attention. But I want to show how we can quickly create a new scenario on EPS and animate it into OP. Okay, so remember that I told you that all the tasks, they are already assigned with the right loader. That's because we imported that from Studio OP. and they are leveled based on the sequence number that we brought from NPV. So we know that all the information from NPV it's already inside EPS. If you want to go back to it, we can. But if you want to create a different scenario based on other parameters, we can test and you can see what works better for you and your mind and your operation. To prioritize my leveling, I'm now going to use my phase number. That means my pushback and my bench number. That means that I'm respecting, prioritizing everything that has a lower pushback number, all the tasks that have a lower pushback number, and all the tasks that have um, lower bench number. That's because OP counts benches from the top down. So the higher bench is the bench number one. But I also want to consider my targets using that level. So I want EPS to create a schedule for me that respects all my targets for total tonnage, plant tonnage, and waste tonnage. So once we have all of this sorted, we can level again. And as you can see, the task changed position. That means some were delayed, some were brought forward, and the tonnage reporting also changed. So we can see clearly what was the change in our schedule. We can refresh our dashboards, and as you can see, now we have no OR gap on the yearly or the quarterly periods, and it looks nicer, so it looks good on the tables, but we need to check if this is an operational solution for our pit. So we'll just come here, let me put this forward, refresh, and then we can animate it and look for some pain points inside, some regions that we may need to correct by creating links or something like this. But if on the overall looks good, that means we created a new scenario that we need to further analyze it and change just small details into it. So for me, that's it. I think I definitely think that I showed you how the information flow from NPV to OP, how our softwares are integrated, and how do I add the information from OP to EPS and create new scenarios. Right? If you have any questions, I'm going to leave our contacts here. This is our Open Pit team, and please contact us if you need anything.